This time I'm going to solve the inequalities that involve logarithm and rational exponents. So question number 1, we have 3 to power square root x plus 3 to power square root x minus 1 minus 3 to power square root x minus 2, and all that less than 11. Okay, before I start solving, we need to identify the domain. And because we cannot allow to have negative number under square root, therefore we have to put condition x has to be greater or equal 0. Okay, now let's start simplify and solve inequality. So we have 3 square root of x plus 3 square root of x times 3 square root of negative 1 minus 3 square root of x times 3 square root of negative 2 less than 11. Here I use the property of exponents, that a to power m times a to power n is equal a to power m plus n. And vice versa, if a to power m plus n is equal a to m, when I use this one, this version, times a to power n. Okay, next step. 3 to power square root of x plus 3 to power square root of x times 1 over 3 minus 3 to power square root x times 1 3 to power positive 2, right? And here I'm using the property of exponent, a to power negative n is equal 1 over a to power positive n. And this is less than 11. All right, so let's put 3 squared. I'll just put 9 because 3 squared is equal 9. So, and I'm bringing two common denominator, the left side. It's going to be, here is 9, so I will have 9 times 3 to power x plus 3 to power square root of x times 3, because common denominator 9, I have only 3, and minus 3 to power square root of x, and this is less than 11. Okay, so do we have same base? Look here. 3 to power square root x, 3 to power square root x, 3 to power square root x. Which means, can I say that I got, those are all like terms. So 9, this 9, plus 3, and minus 1, coefficient is 1, right? So 9 plus 3 is 12, and 12 minus 1 is 11. And I'm getting 11 times 3 square root of x, and this is less than 9 times 11. I got rid of denominator, so what did I do? Since denominator is 9, here also I divided by 9, multiply by 9, and then got rid of it. Okay, so from here I'm going to divide by 11 here, 11 here, which this is gone with this, and I'm getting 3 to power square root of x is less than 9, or I can represent 3 to power square root x is less than 3 squared because I need to have same base. So I can write down, if base is the same, then exponent also same, square root x is less than 2. And what does that mean? Let's see. If I square it, okay, I'll put this way. Square this to get rid of square root, and accordingly square this also. And I will get x is less than 4, right? So now let's figure out what is going to be the answer. Considering this condition, x greater or equals 0, so we have 0 and we have 4. Greater or less than 0, we have to get it positive. Yes, x is greater than 0. So I'm taking this part. So let me take 1. What do I get? The 1 is greater than 0. Let me write down that condition also. X greater equals 0. 1 is greater than 0 and 1 is less than 4. Yes? So that is working. Now if I take this condition is satisfying, x greater equals 0, x is less than 4, its condition is satisfying. Now we want to check the less than zeros, let's say negative 1. So negative 1 greater than 0, so it's not going to satisfy. So less than 0, and same way it's going to be greater than 4, because usually when on some interval it's satisfying interval between two numbers, then below and higher on interval it's not going to satisfy. Therefore, we are going to have, the only answer we are going to have is going to be x is greater equal 0 and less than 4. And that's going to be our solution. Next problem. This is going to be a logarithm related problem. We have logarithm x plus 7, that's by base 4, greater than logarithm x plus 1 by base 2. Okay, it's always much easier to work with equation inequalities when bases of logarithms are the same. Well, let's bring to the same level. What I can do, take logarithm base 2, and it's gonna be equal logarithm by base 2 x plus 7, yes, and divided by this base 2. Okay, so here is the rule we are following, that logarithm a by base n, I can change that logarithm, the base, and I can get logarithm a by base logarithm n. See, I changed to, for base was n, I changed to 10 by default. If we don't write anything, it means 10. Okay? Or you can write, besides of that, you can write down just take natural logarithm. That's also you can do. There we go. Okay, x plus 7 over 2 is going to be greater logarithm x plus 1 by base 2. All right, so from here, what do we have? I can write down, multiply both sides by 2, right? And I'm going to get logarithm x plus 7 by base 2 greater than 2 logarithm x plus 1 by base 2. Yes? So from here, based on properties of log, I can have it logarithm b by base a to power p is equal p times logarithm b by base a. So which means these 2 can come here as an exponent. So we have logarithm x plus 7 by base 2 greater than logarithm x plus 1 by base 2 to power 2. These 2 came to power 2 based on this formula. Okay? So what we're gonna do next, since the bases of logs are the same, then I can drop these logs and I can have only x plus 7 greater than x plus 1 squared. The second condition I would put, it's x plus 1 has to be more than 0, because I cannot afford to have under logarithm negative number. Now, if you ask why you don't put also x plus 7 has to be greater than 0, but that condition will be covered with this one. Let me tell you. So from x plus 1 greater than 0, we get x greater than negative 1, right? Now, from x plus 7 greater than 0, I'm getting x is greater than negative 7. So on the line, negative 7, negative 1. So for the case of negative 1, it says greater than negative 1, which means it's going to go this way. And also I got x is greater than negative 7, so it's going to go this way. So eventually, starting from negative 1, they are going to get common answer, right? Or common restriction. X has to be greater than negative 1. That's the reason. So from here, in second one, I'm going to put x plus 1 greater than 0. Okay, let me solve it. It's gonna be x squared. Oh, I have there squared. Okay, I have to open. All right. So x plus 7 greater than x plus 1 squared. It's gonna be x squared plus 2x plus 1. Okay? Well, and x plus 1 has to be greater than 0. We already know. Okay, let's move everything on one side. We get negative x squared minus 2x minus 1 plus x plus 7. And this is greater than 0. Okay, negative x squared minus x plus 6 greater than 6. Now we need to divide by negative 1 because I want x squared, so I can FOIL it. So I will get x squared plus x minus 6, right? And it's gonna, since I divide by negative 1 everywhere, it's gonna affect my sign also. Negative 1, negative 1, negative 1. And it's gonna affect this one also. So this is going to be equal dividing by -1 here. Okay, so x squared plus x minus 6 is going to be less than 0. And at the same time, we need to watch out that x has to be greater than -1. Okay, let me greater than -1. I move here. And what's going to happen here? If I factor it, I will get x plus 3, x minus 2, less than 0. Okay, if I solve it, x plus 3, x minus 2 equal to 0, x is equal -3, x is equal +2. -3, +2. So what is going to be result? Let's check it. So we have to watch, so it would be less than 0, right? So I'm taking, okay, be in between. I'm taking 0 in between. So 0 plus 3, 0 minus 2 is less than 0. Let's see, this is positive, this is negative. Yes, less than 0. So correct answer is between 3 and 2. But because we have also x greater from -1, where is my -1? It's right here. -1. Then this is going to be cleared, and the answer will be only between -1 and 2. Why? Because when we have x is -3, x is -1, -1 has greater than, -3 has greater than, then the answer is going to be limited by this one, right? Where it's common, both of them satisfying that condition. Okay, so therefore the answer is going to be -1 and 2. Okay, and we solve the last case. We have square root 9x minus 20 less than x. Okay, this inequality is equal to the following system of inequalities, where first condition is 9x minus 20 has to be greater or equal 0. That's one. Second one, x has to be greater than 0. X cannot be a negative number, otherwise under square root we will end up with negative number. And the square root cannot be, result of square root cannot be less than negative number. Let's say if we assign negative number here. And the third condition, it's I'm going to get rid of the square root and write down 9x minus 20 less than x squared. Now where from this x squared popped up? Because if I'm raising both sides to power 2 here. So on the left side we will have 9x minus 20, on the right side we will have x squared. Yes? Okay. All right. And from here, what we are going to get, the third one, it's going to be negative x squared plus 9x minus 20 less than 0. Or I'm going to flip the sign. It's going to be positive x squared, and then it's going to be minus 9x, and it's going to be plus 20x, and obviously it's going to affect the sign of inequality also, and it is going to be greater than 0. All right, so from here, what do we have? Solution has three conditions: x greater equal 20 over 9, x is greater than 0, and here will be what? X minus 5, x minus 4, right? And change the color because we are doing drafting, and greater than 0. So if we solve, x is equal 5, x is equal 4. So on the line of numbers 4 and 5, let me take number between what? Well, let's take less than 4. I'm taking 0. So it's going to be 0 minus 5, 0 minus 4. So it's negative here, going to be positive, which the way it is given. So the correct answer is going to be less than 4, more than 5. Okay, so less than 4, more than 5, and more than 0. If we have more than 0, this x is greater than 0. If we have more than 0, then greater than 5, it's going to cover it, right? Starting from 5. Okay, so what do we have here? We have x is greater than 5 and x is less than 4, right? Exactly what we solved, greater than 5 and less than 4. Okay, so at this point I can x greater than 0, it will be gone because it will be covered by x greater than 5. All right, so this is going to be our solution. So we will have practically our answer is going to be interval between 20 over 9 and 4. Why? Because this is my 20 over 9. This is my 4. So more than 20 over 9, and it comes less than 4. So we need to show it's in between. Therefore, I put in here 20 over 9 has equal sign also. It's right here. Therefore, it's going to be square bracket 20 over 9 and 4. Or we have more than 5, which is going to be 5 and infinity. Okay, are we good? And this is our answer. All right, thanks for watching. Let me clean this, it looks messy. And I'll see you next video.